Today's presentation, October 2025, is from Richard Moy, creating a service-oriented architecture platform with Domino. We'll start with just some introductory comments and then get right into the presentation. Just a quick thank you to our sponsors, specifically Prominec, who has been hosting the Domino infrastructure for OpenNTF for many, many years and provides regular support, and we thank them for their contribution. Our regular conversation about community and the fact that everyone on this webinar is part of OpenNTF, even if you're sitting there watching while you're doing something else during the day today. Just participating in the community means that you're part of OpenNTF, and we invite you to join the conversation and share your ideas, ask your questions, and even share your code. Just a couple of quick notes about changes to the OpenNTF board. We just went through our election cycle. We had a couple of members leave the board. Chris Beckus and Oliver Busa have moved on, and their replacements are Heather Hottenstein and Christoph Adler, so we welcome both of them to the board. I've also stepped down as chair of the board this year, and my replacement is none other than our good friend Sardar Bechamez, who is now currently the longest serving member of the OpenNTF board, and I'm sure he's going to do a great job this year. So he's going to have all of our support. Quick note about upcoming events next week. Next week is Let's Connect in the Nordics, Copenhagen and Stockholm. And I know Vanas has been doing a heck of a lot of work to get that organized, him and his team, and I expect it's going to be a great event. So keep your eyes open for announcements from HCL and other participation in the community next week. And then next month, our webinar, we've had our scheduled speaker let us know they're unable to present, so we are doing some reorganization. But we'll have those details organized here quickly and posted so you'll know what the next webinar is. And we continue to try to work with HCL on the open mic series. I know that with the launch of Domino 14.5, they were all working really hard earlier this year, and so they've been kind of taking a breath, and we're continuing to talk to them about getting the next session organized. So we'll announce that when we have it put together. Quick note about Discord. For those of you that don't know, that's the place that we join online to share what we know and ask questions and stay in touch. And for those of you that aren't registered, please do go ahead and use that link to join us there. And our standard reminder about asking questions, you're welcome to use the GoToMeeting questions panel to ask your questions as the presentation is going along, and then we're going to save them until the end and answer them all at the same time, just so we don't interrupt the presentation, and at the same time can have them recorded so that we can put them up onto YouTube. And as always, this is going to be recorded and edited and posted up to YouTube in just a few days. And with that, Richard, actually want to say other thing quickly by introduction. Richard, for those of you that don't know, Richard is a long time member of the community and the organizer of the MWLUG and Collabster conferences based in Chicago, and he is a lifetime HCL ambassador.
Hi, Graham. Thanks so much for introducing me, and also I'd like to thank the OpenNTF for giving me the opportunity to present today. The session that we doing today is, the title is Creating a Service-Oriented Architecture, or SOA, Platform with Domino. As Graham mentioned, my name is Richard Moy. I'm the Managing Director of Fora Group. I am a lifetime IBM champion and also lifetime HCL ambassador. And I've been working with Nodes and Dominoes since version 3. A little about Fora Group. We've been an IBM business partner since 2003. Our main service provider is business process automation services. And also we're the creator of the Domino-based i4 solutions for no-code application development and process automation. Today's agenda is we're going to be talking about what is service-oriented architecture, what are the benefits of SOA in that approach, And then we'll kind of cover our business use case, which kind of led us to why we developed an SFA architecture on Domino. And then I will go discuss how we did it inside and using what's available in Domino. And then we'll discuss the advantages of using Domino for SOA and also some of the disadvantages of what's happening in using Domino in this format. And then also we'll summarize what we presented here, and then we can ask questions. So what is service-oriented architecture? If you go to Google Gemini, which is now the great AI, they could actually have a very long discussion what SOA is, but what it is a way of designing software where individual, rather than being monolithic, you're building components that build up to make your application and do your business tasks. Most of us, a lot of applications we've built over the years is monolithic, where everything's all packaged up together as one single application, and you build it. If you make changes, you have to make changes within this monolithic solution. In SOA, or service-oriented architecture, the concept is really to break that up into small serviceable modules that you can connect together to perform the business tasks that you have to do in hand as part of your application. Now, some of the advantages of separating the application into services is that first, you can create, modify, and replace these services while affecting other services because they're all encapsulated as individual components. The services does not necessarily have to actually exist as part of your application. It could be external services that are outside, for example, and what I'll discuss later on, the different types of ways of doing it. You have multiple developers developing different services without interfering with each other because the concept is these services are isolated. And also, it allows an agile approach to development, where if your business logic or your business challenges change, you can add new components or services, or replace them with different other ones without having to rewrite an entire application. And also, one of the most important things that is help standardize how you create and build your application. So for an SOA architecture, a service is a reusable component that performs specific and distinct business function. And they're all loosely coupled, so they're independent of each other. And you are using a standard way of communicating between the different services. In SOA, you have what we call an enterprise service bus. And that is slightly different than what we call an event bus. So we'll kind of discuss how they're handled, but it does more than what an event bus does. And then you create a standard communication interface, also use a standard protocol interface. And in addition, you have a central point where you're managing the interaction between these services. So if you want to kind of see a graphical way of representation, a service bus allows you to connect different services, and also the service themselves could be not just an application or a module within your application. It could be connectors that goes into other solutions. So for example, you have a connectors that goes to a different type of database system that's outside your application, or you can connect to external services that are, for example, might be web services offered by a provider. The UI also communicates with, so whatever UI part of your application also communicate with this enterprise service bus, which handles all the communication. So how do we get ourselves got involved in this? And this is the use case that kind of led us into why we developed an SOA platform on Domino. About a year and a half ago, we started launching the first version of our product. And as part of the process of marketing the product, we wanted to provide a free edition of our product. And we wanted visitors to come to our website. They can register and then be able to download a free version of the product from a customer portal. And if you are using products from other companies, whether they're SaaS products where everything is running on the web, or if you want to download a solution, you want to have a very nice user experience. But one of the problems we ran into was that we also got a lot of bots and a lot of hackers trying to get into our system. So we wanted a way to authenticate that there was a real user and providing a real email address so we could validate whether they were real or not. And the issue is that we didn't want people to keep downloading stuff with garbage, and our database would become garbage. So we wanted a way to provide a very smooth, easy to use experience. After the person basically registers, they can go to the online account and then be able to download their license key and then also the installer package, and then they proceed and they get through the installation. So this whole process involved a number of process flows, and we wanted it to be as smooth as possible and having a good user experience. Now this is the process flow for what we were trying to do. And so a person goes to the website, registers, it generates a verification code when they register, which is then sent to the user at the email they provide. And one of the problems is we will always get a lot of Gmail crap. So we basically were just flooding up our database with a lot of stuff. So we have to validate that we're using a real email. So what the system would do is that it generates the verification code and then sends them an email and then brings them to a new form, which then would enter the email verification code, and then it would then validate the license as being valid, creates the license key, and then provides an entry into our CRM system, and then it creates a user account on the customer portal, and then it would automatically email the accreditations to the users with their existing email, and then we would then schedule a follow-up, which is for more for sales. A little more detailed look at the submitting process. The submission form, we also want to make sure that, okay, have they downloaded this solution before? And if so, then we would reject them because we only want to provide one free edition to each user rather than them downloading it over and over again. So the system would check the database and make sure that they haven't downloaded before. So looking at a classical Domino web approach, how we implement this. So you have a HCL Domino server, and we're big into just using what we have, which is Domino. We wanted to basically eat our own dog food in terms of if we're going to promote Domino, why not just use everything in Domino? So we have a Domino web server, which has a database which has a Domino form that has the fields that we want to collect. And then when you do a form post, you basically create a document using the Domino URL. And then inside, when that document is saved, it does a query save, runs a query save agent, and then if it does the process, it creates the verification code, and then also sends out the email to the person. So then after that's complete, in the $$ return of that form, it would then redirect you to the verification form. When the individual visitor receives that email, then they would submit in a new form the verification code and the last name, and then run the query save agent that essentially now creates the entire process that chain that I just showed you in a previous slide. And then in the dollar, then you would go back and then say, thank you very much, go to your email, and you would get the accreditation to log in and download your license key and be able to then download the installer package. But this thing had a lot of drawback. For one thing, all your business logic and data is stored in one database. That increases your vulnerability to potential data breach. The process itself is synchronous. So if the process is very slow, the experience is very slow in getting the information that you want. And also, it's very monolithic in design, which makes it hard to maintain. Any modifications would take you simple changes to the whole design, and you got to do a full testing process to make sure that one small change does not affect a very complex application. A modified approach would be to separate the business logic into another database which has no web access. So you can secure the information that actually is doing all the business logic and all your internal operations on a run on server agent, and you basically have the save query agent trigger that run on server agent that is actually on a second database which has no web access. So that's another approach to improving your security and separating your business logic from the front-facing application. A better approach would be, now you think about it, you want to keep all your business logic, all your sensitive information on a separate server, which has not only no web access at all for the entire server. So all the front facing is now just on the server one, and then everything that's on protected you want to have it on server two. And the only way they're communicating is through encrypted NRPC, which is a lot more secure than being in an HTTPS. But the best approach would be to provide all the solution, all the stuff they do have for front-facing in one server on a separate domain, you say a public domain, exposed domain, and then also have all your business logic, like your CRM, your license information, on a separate domain that has not only no web access, but has no public-facing capability. So that was the best approach that we wanted to do. So looking at the overall picture, you have a license server, the database server, CRM server, which are the private servers that are internal, and then the custom portals server and also the web server who are front-facing on a separate domain. So that and you could even have the custom portal server separate from the web server domain because you want to protect that further, though it would be under a wall of being able to acquire login. But that's the ideal situation. So we want to implement this best approach, and we got this, which we've never seen before. And we looked it up and said, well, why can't we do it? Maybe we made a mistake somewhere in configuring our domains. So we double checked to make sure all the different domains were cross-certified. And then we checked to see if they were set up for a trusted server. And we rebooted the server just in case there are some problems. We resaved everything, and we still got this. And it was very frustrating. So it was like, well, what are we going to do? It's because we're like in Get Smart. I don't know if you guys are familiar with Get Smart. Now, I'm old enough to know and watch Get Smart when we were kids, but we kind of felt like we missed it by that much. We're so close, but we couldn't have it. And then we've discovered that actually is an aha request. It is a problem. No matter what you do, if you're run on server agent is running on a separate domain and you're being called from a different domain, you will get this error. So we said, well, this whole idea of trying to keep everything separate in different domains won't work. So we said, well, maybe we would do a pragmatic approach to how we would basically think about this. Could we use a mail-in database to trigger the run-on server agent that's on the different domain? And the answer is yes. People have done it, very similar thing, and Vern has had sessions in DNOC and also Engage called Event-Driven Architecture in Domino. So if you're interested in that, I would encourage you to go to the Engage website and then download that presentation. But if his base is on Event Bus, we wanted something a little bit more different, so we want to expand on that. So using the pragmatic approach, we did create a mail-in database. We had views for the memo documents to be received, and we used that view to find these memo documents that gets triggered by the web save query agent. And then we had a scheduled domino agent that is triggered when a new document appears. It's a standard method a lot of people have done. And we add a code in the web agent to send that memo to the mail-in database. And then we add a code in the web agent to create a document that stores all the data that we submitted to the run-on server agent that I mentioned before. And success. We were able to communicate with that new domain from the public-facing domain. So we said, wow, this is really great, but it was very, very slow. And I said, why is that? Well, there's a reason. Run scheduled agents that you run on new documents are really inconsistent on when it happens because these agents run on their own schedule. And regardless of when you enter it, it always is a minimum of 5 minutes. And if you're lucky and the event you call is in less than 5 minutes, then you'll have a better response. But that was a problem for us because imagine if you go to a website and want to be able to log in. In many cases, a lot of sites now have a two-factor authentication process where when you log in, they'll send you by email or by text message a authorization key that will verify that you actually are valid or not. Imagine if you push the button and then you wait 10 seconds and it's not coming in. What I do, I keep refreshing my email and then nothing's coming in. Then I'll push to have another request. But waiting 5 minutes is an eternity in our world of internet. So we have to find a faster way of doing that. So we looked at another event, trigger events, after new mail arrived. Well, a little bit faster, but inconsistent again, because it depends on the mail routing activity of the server. And it could be reasonably fast or it could be slow. It depends on the load on the server. So that was inconsistent and we didn't feel comfortable with it. And then I was in discussions with on OpenNTF Discord, which I encourage everyone to get onto. And someone suggested before a new mail arrives and said, yes, wow, this is the way to do it. It's not affected by mail routing and there's no delay and it triggers immediately. So our best approach was successful. I said, wow, what can we do with that now that we know how to do that and it works? Could we, in our process flow, utilize the concept being able to do the triggers since our flow actually consists of a whole bunch of individual modules. in this case, services. And could we build an SOA platform on Domino? So it's quite hard to think about it. How can we build that? So, and make this possible and be able to reuse the different components that we are creating in this thing. So could we use this approach for making a very flexible application using SOA approach? So that's the kind of epiphany that we spent a lot of time thinking about. Me and my partner, we had a lot of discussions on what's the best approach. So our vision was to take that whole process flow and now put it into the form of how you would do it in an SOA type approach. So you would have this enterprise service bus, which right now was something we were thinking about. You have all the different modules that can be represented by a service. So if you think about what a service is, sometimes called a microservice, it's actually similar to what a run-on server agent is in a loose sense. So a service needs to have reusable components, which you could do with a run-on server agent, and it has to perform distinct business functions. They need to be independent of each other, but you need to have a standard interface to communicate with these run-on server agents. So this is an expanded version of what the previous slide of what we would envision an SOA would be on Domino. So the RASA, which is run-on server agents, we would have a whole bunch of them. We then connect it to our ESB NSF, which is our mail-in database, and then all the communication will go through this event bus. So now we have not a true event bus, but we want to be able to make it into a enterprise service bus, which is slightly different. I'll discuss that in a few minutes. So that was our main goal in how we got from having a business use case for something else that's kind of evolved into how we would have an SOA on Domino. So we spent a lot of time experimenting, playing with it. We have kind of advantage that we're creating software for ourselves, and we're creating software that we sell, so we can experiment all the time. And we envisioned how we would actually make a mail-in database become a enterprise service bus. And the service bus is different from an event bus because the service bus has to be able to not just react to one event, it has to be able to react to one event and then be able to chain those events into multiple services and then be able to manage and control the whole thing. So we came with 3 types of documents. Event document, and we'll describe each of these documents and how they work. So we have the event document, we have the payload document, and a transport document. An event document is the service chain. So in other words, is when you have a business task, you have a series of different processes you have to do or services that you have to do. And what an event document does is define what happens in each of the servers, where it's located, and how you call it, and what agent is used to run it. For example, in the first one here, we have the first ID, which is Apple, okay? So you have to have an ID to identify that particular service. And then it tells you what server you're on. In this case, when you have multiple servers in our environment, you want to know what server, and then also where is that agent located and what database. And also what service bus you would use. Now, in general, you will have one service bus, but I'll discuss later on, you have multiple service buses, enterprise service buses. And then what agent you're going to be running. And then async, which I'll describe in a few minutes later, whether it is no or yes. And then as part of processing, you might want to add additional data to what you want to do. And then also the next ID is what the next service you want to run after this service. So that is an event document. So it's basically the guidance that how you connect the individual services together to achieve your business tasks. So what that is, that event document and how you process it brings you from an event bus to an enterprise service bus. So a payload document contains the information that you posted in your web form in this case. It's analogous to the Domino agent parameter doc. If you think about it, if you are connecting one agent to a secondary agent that run a server agent, you want to pass the data, use the parameter doc. And that's very similar analogy to it. But it contains more than that. It contains, for example, the event ID. The event ID itself is, okay, what event document? So in the case for what my previous event document, so the event one was defined by that particular document. Also, the service ID is, okay, what service, which of the array of JSON in this event document, which one are we going to be running? And then also is what agent are you be running? Which agent is going to be the subscriber to this event? And then we'll also include the information that you submitted. So as part of the last thing is the transport document, which is memo document. It is basically the trigger document that causes the actual event to occur and then triggers the service that you want to have. And inside that transport document, which is essentially a memo, the memo document or email document, you have the subject, the universal ID of the payload document that you created, and then also what server is running it and what domain, and also the database that has that particular run on server agent, and then the name of the agent. That's all you need. And this transport document is the main trigger for all the different events. You will have, and if there is multiple services involved in the business tasks, you will have multiple transport documents. So looking at it more as a graphical approach, we have the trigger document that actually triggers the service bus to run. And it creates a publish process, and it basically tells that, wow, something has happened, I'm launching and I'm publishing. And inside the publishing process, you are notifying the runtime server, which runtime server agent that should be subscribed to this event. So that description, that runtime server agent basically would then react and basically look in the view and say, oh, there's something here in the payload view, and then basically capture the information from the payload document and then run its tasks. Now we have a situation we mentioned about async, yes, versus async being no. So what we have in our situation, we have services that are asynchronous, where you basically fire and forget, and then you continue the process, the service chain. Or we also have situation where no, it's not asynchronous, it's a synchronous process. You want to be able to complete the tasks that's done by the runtime server agent, and then return back to the next event in the service chain. So what happens here is that when it is async equal to no, what happens when you start the publishing process, it automatically sets the listener to waiting for it to come back. So when it runs it and completes this process, that run on server agent then broadcasts back to the listeners that, oh, I'm done, so that you can continue on in the service chain. So now I want to kind of talk about how this is done. So in the publishing run on server agent, its main trigger is the before mail arrives event. Everything's a non-blocking process, and there's a reason why you want to be non-blocking, because what happens if you have one agent call another agent, it becomes a blocking process and is a synchronous process, and nothing happens until the whole thing is completed. And if you start chaining a whole bunch together, now everything, if one thing fails or if you don't need to have it blocked, it will block. And so the approach we did was to first you create the payload document, and then rather than having you call the agent using the other agent, you actually call it using a send console command. And now you actually have a asynchronous agent call, and it fires it out and it does what it needs. But the way to do it is that in the transport document, you actually have information of what target server and domain it is, and so also you have the target database path. Also, you know what the agent you're going to use, so you can send the command using command line, and now you're out and running. Now, the publishing run on server agent, when you set it to yes, you only can actually run run any type of schedule agent, but my recommendation is disabled schedule agents. And the run command works with schedule agents. What it does, it scans the event bus view to look for payload documents that are associated with this particular run on server agent, and it's been assigned to it, and reads those payload documents and then runs the business logic, and it's done. It doesn't need to have a send response back to the bus. So when you run this particular event and it subscribes, the service bus would then go to the next one because it's not blocking. While when you have a synchronous process, the subscribing run on server agent, when the async is set to no, it is also does the same thing as what you have for when it's async is equal to yes in a asynchronous process. But what it does is then it goes to and look at, okay, what is the next service in the service chain? And looks up that in the event document. And then it creates its own payload document and then onto the bus itself. And then it does a transport document, and then it sends that to the mail-in database, which is the ESB. And then you go to the next particular service in the service chain. And you can do this, and this is a little more a description of how things are. So the first one you fire off, and then it loads the next service. So you can have a mix and match of asynchronous and synchronous services that you want to run. So now you actually have a SOA platform on Domino. So a little more detail how the process works, and in the case for what we were doing for our web query agent, you get the information from the service chain from the event document. It knows what you know what you want to do. You create a payload document, then you create a transport document, and then you send that transport document. Basically, you're emailing it to the mail-in database within your Domino server, and then it triggers the publishing agent by going through the before mail arrive arrives run on server agent. You run your service, and then that service loads the payload document with information you need to run your business logic, and then it then repeats itself if there's any more services within the event document for that particular event. So we structured the enterprise business bus database, which is now our mail-in database. So all event gets triggered using the before arise on event. We have event bus download views that keep track of different payload documents, different transport documents coming in, and also we have an additional schedule agent that repeats the process in case something didn't get triggered, and it's kind of as a failover situation. And it has the event documents, the transport documents, and the payload documents. You can actually serve it as your process log, and so you can use it to trace back if there's any issues that you have found. And we've done it many times where we actually have set it up so that if it fails, we only mark it as error, and then when that a person looks at the log, they can say, okay, this is where it failed. And you can actually see how it fails. So, for example, if you have a chain of 4 services, and you can see that, on the third service it failed. Well, something went wrong. So it's easy for you to track down. So yes, it's possible to have SO platform on Domino. The services, as we mentioned, when we compared to what we had from original chart, is that a service is run on server agent, particularly disabled schedule agent. It works well with that. It's loosely coupled. The run on server agents should be designed to only focus on specific tasks or activities or functions. And we have our communication protocol. Everything is done through NRBC, which is secure and encrypted. Our enterprise service bus is our mail-in database that has been supersized with the ability with the transport document, with the event document, and also with the payload document to help build the process. Our standardization for us is JSON for the payload documents and event documents, and everything we do at our company is in JSON format. You could use XML or some other methodologies to store your information, but as long as the interface between the different services and between the different components of your application is consistent, that is what's important. So don't mix things around. It just follow one fixed format, and you will be able to make the life a lot easier. This enterprise business bus, NSF, is the one that handles everything. You can go through everything. And I'll kind of discuss in a few seconds the advantage that Domino has on this. So one of the biggest problems with an SOA platform is that SOA relies on this enterprise service bus. And that is kind of like the single point of failure. But one of the nicest things about Domino is that we can cluster multiple servers together and have them in sync. So one of the advantages that Domino has is that in case one server goes down, you can immediately have the other servers take over. So you can have clustered ESBs databases, and so your failover rate is a lot less than what you do for other platforms. You could have multiple ESBs also. You can actually have one for your public facing, or you have one for internal, or you have many you want. You can have bidirectional ones where you can actually have one calling the public facing one, public facing calling the private one. So you have this more flexibility. Now, we never tested that way. In theory, it works, but it can get very complex, so that it takes a lot of time to set that up. In a situation for how we have presented here today, we have asynchronous and synchronous services that are running processes. And we have one of the biggest advantages that Domino provides is that we have the secure NRPC protocol, which is extremely safe to use, and it's encrypted, and all communication, I don't know if anybody has actually broken that protocol, but everything's handled privately, while in other ones they're using either XML or HTTPS, which give you a higher chance of, because people understand that those protocols and those interfaces better than NRPC. Kind of like, we have Vanish because less people know about it. It gives you a chance to do automatic logging by being able to store all information in the payload documents or in the transport documents, so that you have a way of tracking things down. And then one of the huge advantages here is that you can have all the stuff running in different locations, different servers, different domains, and it provides a true distributed computing environment. Now, some of the disadvantages that there is a small delay between running these services using this methodology. And one of the things we're seeing from how people write stuff, you have to have really strong disciplines of making sure that these run-on surveys are independent and self-contained, because you need to have that requirement in order to make SRA work. This may not apply to you, but one of the biggest problems we see that Domino has is those low script JSON parser is not really adequate to really manage the JSON data that is coming in and out of the system. Now we have our own parser which we use that is provides us the capability we want, but that's not something that is publicly available. So in summary, can one deploy an SOA architecture on HCL Domino? Yes. It provides you a much more flexible and agile approach in developing complex processes. But HCL Domino provides you advantage over other platforms in terms of security and resiliency. So yes, you can teach an old dog like Domino new tricks. And now for any questions.
Thank you very much, Richard. You could probably keep your slides up just in case we want to traverse back and forth.
Okay.
So reminder to folks to pop your questions into the questions panel. We've got one here, and I got a couple in mind. And Jesse, feel free to jump in as well. You more or less answered the question that was popped in here, but Bob asks, wouldn't the Domino REST APIs be able to fire agents across servers? And you more or less answered that because you wanted to stay in NRPC, but I'll let you expand on that.
Yeah, just looking at the OpenNTF Discord, a lot of people have problems with running agents using the REST API. I wouldn't say, yeah, I guess you could use it, but I prefer to use NRPC. The reason why is a lot more secure. The reason why we went through this whole process because we're paranoid about separation of how data is located, and we've seen so many cases where supposed to be fully secure environment, but I think we're fortunate to be able to have multiple protocols that Domino supports, and I would say I would definitely not use HTTPS, and also the complexity of setting everything up in Domino REST API, it would I think just slow things down. So
yeah. And you mentioned it there right at the end, but your development language of choice is LotusScript?
Yes. You can do in Java. Unfortunately, I am not Jesse, so I don't have the capabilities of correct developer. Wherever it's available, we try to figure out how to do. We're always like that. I don't know if you guys are familiar with Asymmetric Toolbook. It's one original Windows-based application development program. And when we were running Recore, we didn't have the capabilities of writing C code. So we actually used this product to create a simulator. So our approach is take what we have and then figure out how to solve the problem. So
yeah. Yeah, I remember talking to you also as you were working on this about the challenges with the Lotus script JSON parser. A question just comes in: why didn't you simply put the fields inside the documents just as regular notes fields instead of JSON? Why did you choose JSON as your main data store?
Because the programming interface we created for ourselves is all JSON. So all our functions, classes, and everything run on JSON. So since we already have the high performance JSON, Lotus script JSON parser or flex parser, we utilize that often. I mean, you could use XML as part of the protocol, wherever you're comfortable with. You could put in fields, but then you would have. So, for example, think about a situation where you'll know what the fields are. So if the form post that comes in, that means you have to create custom forms for each post you have. And if you're running applications that have 30, 40 forms, that becomes a nightmare. But having it in JSON form is so much easier. And we've had a lot of experience with JSON, storing them. You could store, we stored like 3-4 megabytes of JSON using mine fields, and it runs just as fast as regular fields. So why bother creating fields when that's another task? The concept of creating fields goes back to how you would do it in Nose Client. Our applications don't run on Nose Client. We haven't done Nose Client work in almost a decade. So except for internal stuff, sometimes we do it, but we love the JSON format. So.
And just to clarify there, so you said you store it in a MIME format field, basically a rich text field?
No, not rich text field, a MIME field. So you can store megabytes, or actually you store more than that, but we in general store megabytes of JSON in a MIME field as just a JSON string, and then we convert it back into a JSON object when we need it. So.
Yep. I actually remember sitting at Lotusphere many years ago, talking to Nathan Freeman of all people about exactly that concept, and it was completely new to me at the time, and it absolutely blew me away.
Yeah.
Jesse made a comment just as you were talking earlier there about the nice aspect of this approach is that it could let you use whatever language and mechanism makes sense for each of the steps in the process. Just by breaking it down, you can use what you want.
Yeah, we actually, originally, we actually have modules that are Java, so Jesse would make him happy. So, the nice thing about this approach is now we do it using our process automation platform, but you could now have when these services call an external service, like Zoom or even GoToMeetings to do something. You could have that service connect to the download REST API to make that call and then come back. And that's just one particular component in this whole SOA chain that you want to do. So it's a really flexible. So even in our case, one of the services, because it's simple to do in Domino, is to send an email notification to someone. Well, one of the things that we're actually doing right now is replacing that Domino-based service with actual a product called Mailer Send. So it will call that service out. And one of the nice things that Mailer Send provides is that we don't have to worry about dealing with DMARC and everything, and Kim and everything. You just send it to that service, and the service takes care of it for you. So
very nice. We got another question here from Javier. Good to see you on the webinar, Javier. It is said that one disadvantage of SOA architecture is logging, as you don't have a central log, but many of them distributed across. How was your experience with this?
We have our own, many years ago, when we were doing our product, we created our own logging capability. And it basically aggregates a whole bunch of different logs into one single log, and allows us to track everything. And you actually could go through the process of seeing things progress, and then you find out where it failed. And
Yeah.
as we were doing this, it happened so many times that I would be, working on this thing like at 2 in the morning, trying to figure out what the hell happened. And sometimes the log won't capture it, so you're putting message boxes everywhere, looking at the server console, like, okay, where did it fail? So
Yep. Yeah, I think so basically the answer is that you built your own custom logging mechanism. I think
yeah,
that all of us that have been around for a good many years have learned to take care of ourselves, our
yeah,
future selves, simply by coming up with some clever logging mechanisms so that
yeah.
like you say, at 2 o'clock in the morning, you can find out where something broke. All right, that's the total of our questions, Richard. So I
Oh,
think we will wrap it up here.
okay.
That
Thank
was
you very much
wonderful.
for having me.
Yeah, thank you for your time, and thank you everyone for participating today, and we will see you next time.